Hi, I'm Imran, and as you can see, I'm a plumber. I've been called to this house today because the owners want to redesign their kitchen and move their sink to a different position. I need to look at where they want it to go and work out whether the waste pipe can be fitted with the right travel or gradient to meet with building regulations. It is vital that you get this right. If a travel is too shallow, it means that the wastewater won't disperse properly and stagnate. Now, building regulations state that there must be a minimum fixed ratio vertical drop or offset to horizontal run. So, for every meter the water has to travel this way, it has to drop at least 25 millimeters this way. I've measured the distance from the proposed new position of the sink to the outside wall, which is the run. I've measured the offset the pipe needs to drop by. I've checked the gradient complies with building regulations and can now calculate the length of pipe that is needed. Pythagoras' theorem can tell me that. Imagine a right angle triangle where the offset is the vertical height and the run is the horizontal length. The pipe I need to fit is the hypotenuse of this triangle, and its length can be worked out using Pythagoras' theorem. Remember, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Right, now, before I leave, the owner says the lounge is very cold and the radiators are very old, and can I give her a quote for new ones? But first, I need to work out the size of rad I need, and to do that, I need to know or work out the heat requirement of the room in BTUs, or British Thermal Units. So, first thing I need to know is the volume of the room, and to do that, you need to multiply the length of the room by the width of the room by its height. So that's 10 foot by 12 foot by 8. BTUs are always worked out in feet, not meters. Always worth remembering. The ideal temperature for a lounge is 21 degrees. So I need to fit a radiator that will keep the room at that temperature. Kitchens and bedrooms need to be less warm, bathrooms need to be warmer, but for this room, I get my BTU figure by multiplying the volume in cubic feet times a factor of 5. So that is 10 by 12 by 8 times 5 equals 4,800 BTUs. But the story doesn't end there. Not all rooms are made of 4 solid walls. You might have French windows where you add 20%. Or the room might be facing north, so you add 15%. But if it's got double glazing, like this room has, you take away 10%. We have our BTU figure of 4,800. 10% of that is 480. Take that away from the 4,800 to give the final BTU figure of 4,320. So, looking at my chart, I think I'll recommend a radiator with a BTU output of 4,800. That should give out plenty of heat. I always round up and not down. And I think the one with the height of 500 millimeters and width of 1,600 millimeters will suit the customer best. Job done.